Hello and welcome to my undergraduate research presentation. This is a visual improvement to the pedagogy of introductory logic. Okay, so let's talk about what that actually means. So, formal logic is one of those subjects that confuses a lot of students when they're first introduced to it, due to the esoteric notation, confusing symbols, and relation to discrete math, which can turn many away. One thing that we've noticed is that students prefer and enjoy having hands-on exercises to work through. Practice makes perfect after all. Plus, there are tools online that help facilitate this, but they're few and far between and generally rely on the student already being an expert at the material, a rather precarious assumption. Thus, we present LLAT, the Logic Learning Assistant tool, an in-progress application to encourage a hands-on experience that complements the traditional textbook and lecture pedagogy. So, what does LLAT do? Well, it allows students to practice with propositional and first-order predicate logic, the two primary subjects of introductory logic courses, by building and constructing sentences with logic symbols. From here, they can run several algorithms or processes on the sentences that they create to understand the relationships between them and what that sentence actually means. We'll show a few examples of this later. Okay? So on the center of the screen, we have a list of all of the algorithms that are available for the user to choose from. Alright? So our focus in this project was to improve the learning experience rather than just provide a tool that simply gives answers when prompted. While it is capable of doing that, we aim for students to solve the problems first by hand, then check their work later to see if they messed up. Further, we designed truth trees, one of the algorithms, to give steps in each derivation as shown in figure 6, and we'll blow that up in a minute. Moreover, in the right pane, we offer explanations, definitions, and alternatives to each symbol type. In case the student is using a different notation, they won't be confused. And we plan to add more examples and improved definitions later. So let's go to slide 6. So as we can see here, we are using a truth tree. And here is the sentence that they inputted. And this on the right side is the symbol name, the formal name, alternative symbols, and a brief explanation and some examples. And again, we're going to improve these as time goes on. As we can see over here in this little tooltip, when they hover the mouse over a step in the truth tree, the list of reasons why that step was derived shows up. Alright, so let's go back. We also allow the user to create an account to save their preferences, such as their theme, preferred language, and the last 10 sentences used. Now, creating an account isn't necessary to use the application, but it is convenient if someone wants to save their progress in the cloud and then log on somewhere else. Alright, so now let's move on to the discussion. So many of the algorithms and features that we wanted to include, or did include, do not have what are called efficient solutions. This means that a computer cannot solve them in a reasonable amount of time once a sentence becomes too complex or too large. We implemented a timeout feature to prevent the user from entering such formulas that are too difficult for the system to handle. Moreover, we wanted to allow the user to view the application in any language that they wanted to help them better understand the material, so we implemented a translation system. However, the translations can be a bit hit or miss, and as we continue development, we plan to improve upon the algorithms and the translations. Alright, so in summary, we wanted to give students a way to learn formal logic without getting confused and lost. We hope that with this new tool, it helps them better understand it. Finally, we would like to implement more algorithms, such as proof-based natural deduction, better random formula generation for both propositional and predicate logic, improved error and warnings for the user, and much more. The continued research and development on our part will further refine the educational experience. Thank you very much for watching. We would like to thank ERSCO for their support, Dr. Kim of the Computer Science Department, and Dr. Lawler of the Philosophy Department.